Hello, in this lesson, I would like to talk about some examples of applying substitution rule for definite integral. You can see that for indefinite integral, we just do substitution. We don't have to worry about the interval. But for definite integral, we have to take care of the interval if we change from dx to du. So in this example, I'm going to choose some homework questions from to explain to you and also show you how to show work. Okay, so start with the first one. We have an integration, which is definite integral, that we want to find the area between the curve and x-axis. And remember, this is a definite integral. So as we're changing from dt to du, we also need to change the interval at the same time, okay? We must know that we must do this change at the same time, all right? And don't mess up. Okay, so let's get started. So this integration is from 0 to t with differentiating cosine of pi over t divided by 2. This is on differentiating on t. And since we're going to do substitution, one of the substitution we can do, we're going to use u equals to pi t divided by 2. Okay, or you can write it as this way, okay? Pi over 2 optional, okay? Optional times t, because this way we separate the constant part with the variable part, okay? And then what is du? du dt. The derivative of u with respect to t, and we take a derivative of u on both sides, so we get a pi over 2. Pi over 2. And now by this time, we see that we get du, we multiply dt on both sides, so we have du equals to pi over 2 multiplied dt, right? So dt and du has such a relationship we can use, okay? At the same time, we need to change the interval. How do we do that? We're going to make a table, okay? We're going to make a table. Actually, you know what? I'm going to show you another way. Before we create the table, right? So now this time, I'm going to solve for dt. So dt is if I multiply in this relationship on both sides by, okay, I'm going to show you clearly, okay? So I'm going to multiply on both sides because I want to isolate dt. So I'm going to multiply on both sides by the reciprocal of pi over 2. That's going to be 2 over pi. So I'm going to do this on both sides, 2 over pi. So this way I will be able to isolate t because this makes 1 and dt would equals to 2 over pi multiplied du. Okay, we can remove the dot. By doing so, as you can see, we're going to transform this to the next step. Okay, and the cosine is the cosine u, okay, because u is pi t over 2, and dt will be replaced by 2 over pi du. So the next part to be replacing is the interval. Okay, so now we're going to make a table. Okay, we're going to make a table. And how does the table look like? I'm going to show you the table. 3 rows, maybe 3 columns. If we don't need it, we can just reduce it. So for t and u, okay, t is is from 0 to 1. U is, what will be the value for U? Because U is equal to pi over 2 divided by pi over 2 times t. So when t equals 0, we're going to multiply, we're going to plug in this relationship, multiply t by 0, and that is going to equals to 0. And for the next u, for t equals to 1, we're going to replace t by 1. So we're going to get pi over 2. We're going to get pi over 2. So now interval is going to change. We don't need the third column. So the interval is changing from, for t is 0 to 1, and for u is 0 to pi over 2. Okay, so 0 change to 0. T equals 0 change to u for 0. T equals to 1 change to u equals to pi over 2. So let's come back to this piece, and where it's going to be 0 to pi over 2. So this is the complete change we have made. And you change everything from t to everything in u. And all these change must take place at the same time. Okay? All of these must be taking place at the same time. Please don't, okay, these are the mistakes I've seen before. Okay, so I'm gonna put it here. Don't do this. What do I mean? Okay, I see this kind of mistake often. Instead of doing this, right? Some people would do this to be 1, right? Didn't change for t. Or this one is still dt. Okay? These are incomplete because you have to change it completely to the other one. So don't do this. Or the other case I saw is that you need to change it completely to du. So this, and you didn't, even you change everything to u, but you didn't change the interval. And you, in your next step, you change it to the interval. Then you say, would that be okay? The answer is no, because this piece was completely you have 0 to 1. You already made a mistake, right? You already made this already a mistake. So let me show you how the grading is done, right? You already made a mistake here, right? Because this is from 0 to 1, you change it to u, 0 to 1. That's mistake number 1. And then for u from 0 to 1, you change it to u from 0 to pi over 2. That's another mistake. You made a mistake twice. You made a mistake twice, okay? So please avoid this kind of mistake. All right? So please don't do that. Please don't do that. So avoid it. Just take your time, right? Set it up and put it together. Okay? All right, so let me clean this up. Okay. All right. So this is step 1, step 2. Okay, so from step 1, step 2, all these work need to be done. And you can put it on the side. So now we can complete our work. Okay. So to complete our work, oops. Okay, so, oh, never mind. Okay, so I'm going to continue the integration, but this time I'm going to continue. Oops, what's going on? All right, so I'm going to put this. Okay, now it's better. So we're going to continue working on this. 2 over pi is a constant, so I can move it out. Okay, cosine u du. And the next step is you keep everything, you don't change, unchanged, and the antiderivative of cosine u is sine u. And evaluate, right? Evaluate at 0 and evaluate at pi over 2. Almost finished, right? So we have 2 over pi still. Multiply, we're going to apply the fundamental theorem of calculus part 2. So it's the cosine pi over 2. I'm sorry, sine pi over 2 subtracting sine of 0. And the final answer, sine 0 is 0. Sine pi over 2 is 1. The final answer is 2 over pi. Finished. How to show work. This is pretty much how you show work. Okay, so let me make the fonts a bit smaller so you can see the whole picture. Right? You don't need to write these. You just show work. You can show it vertically, right? So you assume the U, and you show this part on the side. You can show this part on the side. Okay, you can show, it's harder for me to show it in this. For example, what I meant is that you can do all of these. Okay, you can do all of these. Okay, and put all of these part, right? Put all of these part on your paper just on the side, on this side. Okay, so you can put those other work on the other side. I can't do it. Let me see if I can have, let me see. Okay. It won't be, I won't be able to do it easily, but on paper, you just put it side by side. Okay. So this part of work, okay, this part of work and the part of work above, you put it side by side. Okay. Actually, I can show you. Yes, I can. I just realized I can do this, right? I can do this piece. Okay, I'm doing a screenshot. I'm doing it again. Okay, so I just want to show it to you clearly. You can show your work, this part of the work, right? Okay. Over here. Right? And the other part of the work, screenshot. And this part of the work, just next to it. So when you show your work on the paper, on the paper you turn in, you have your entire paper, which is the whole of it. On the left side, you have this. On the right side, you have that. Right? So you can lay them out like this. Okay. So make this like show work. That's how that's how you can show your work. Okay. Or completely all vertical. All vertical is fine. All vertical is fine. So that's the first example. So let's look at pick up another question. Okay, and this one I'm going to pick up 59. I'm going to pick up 59. Okay, and it's a definite integral. Okay, so integration of function interval is 1 to 2. And the function is e to the power of 1 over x divided by x squared, and then dx, okay, and dx. So we're gonna work on that, okay? I'm gonna put it on the top because I want the formula of substitution right underneath, so for our reference, right? So that was the first question. So let's look at how we're gonna do this one. The idea is similar, okay? So first, we realize we have to do some substitution. Will the substitution be possible, right? So we're gonna choose u equals to 1 over x, okay? Which is u equals to 1 over x. What is the derivative of u with respect to x? Du dx. And that will equal to negative 1 over x squared, right? Therefore, du is equal to negative 1 over x squared multiply dx. And we already have it. We have dx over x squared, right? We already have that. So we are different from du by one sign, okay? But at this point, you can express 1 over x squared multiplied dx equals to negative du. So in our substitution, you're gonna have integration sign, right? And dx over x squared, that's already negative du. Negative du, but how about e to the power 1 over x? That's e to the power of what? U, e to the power u. And how about the interval, right? You can see the substitution, this is e to the power u, and that make a negative du. So the next thing we need to do is we're gonna fill up these two numbers. So the interval change, right? Interval change. So take your time and do the interval change. Okay, we don't need 3 columns, a 2 column is fine. So we have x, we have u, right? 2 equals to 1 over x. When x equals to 1, u equals to 1 over x. 1 over x is 1, 1 over 1. If x equals to 2, u equals to half, right? They're reciprocal to each other. So by this time, so x equals to 1, when x equals 1, u equals to 1. So 1 goes here. When x equals 2, u equals to half. So half is going to go there. So this is a substitution is done. Substitution is done. And next step, okay, we're going to, of course, we're going to do the integration. Put the negative, take the negative sign outside. Okay, so the whole of it, we're going to bring the negative sign outside. So that's the integration we're dealing with. But if you also notice the number from 1 to half is smaller than 1, we can switch half and 1. If we switch half and 1, it generates another negative sign, okay? So if we switch the interval, right? So this becomes half. This becomes half, and the top is 1. So this switching generates another negative sign. So negative makes what? Makes positive. Boom, boom. So after this switching, the form is easier. And that equals to e to the power u. Evaluate, right, at half. Oops, sorry. At half and at 1. So in the end, we get e to the power of 1, subtracting e to the power half. E to the power half is square root of half. So this final answer is e minus square root of e. And we're finished. We're finished. Okay, so let's see how we're going to show work. Okay, the preferred form of showing work. You know, I do this for convenience during the lecture because then you can see everything, right? On paper, I like to see things vertically presented. Like most of the professors, they like to see things vertically presented. I can care less about it, but there's a one version of showing work, right? So let's see. Wait, hold on. Okay, so I'm going to make the fonts just a little bit smaller. Let's do some screenshot, right? So this is the beginning, all the way up here. So you show your work like this, right? That's one piece. Okay, the next piece you can show your work is on this part. I'm doing the screenshot, okay? Side by side. So this part of the work, you can do it right by its side, okay? Show your work. And there you go, okay? So, oh, that's ugly. This is better. It was okay. It was better then, okay? And just put them side by side, okay? That's how you show your work, okay? So this way, I think it takes less space, especially you have those it stays on your paper. You just divide your paper into two parts, okay? Right in the middle or 2/3, 1/3, whatever, it's up to you, okay? So let me let's see if we can get we'll do another question. I'm looking at a question 67 and 69. Okay, so I'm going to do 67 and 69. So let's copy the question and bring back to the 200% we had before. Oh, wait, well, how did I get 2 copies? No, we don't need 2 copies, okay? Just 1 copy. So 67 and 69. 67, it is not because it's so hard. It's just, it requires some algebraic skills, okay? So we have the interval is from 1 to 2. And the function is x multiply root of x minus 1 dx. Okay, and the next question, I'm going to just to copy this time, is integration. And we have e to the, there's e in the bottom, that interval, and the top is, it looks like e to the power 4. I got to double check. I probably need to put on my glasses. E to the power 4. Okay. Dx, I'm going to double check that. Dx over x times square root of ln x. For you, you may like to just turn it off and try your own and then come back to watch the lesson. Okay. Is this e to the power 4? Let me check. Yes, it is e to the power -4. Okay, I'm going to just double check if that's your homework question. Yes, it is. Yes, it is. Okay. So we're going to work on these 2 questions from now on. Okay, so I'm going to bring them to above the two substitution rule. Okay, of course, we're using substitution for definite integral. Okay, so now the first one. The first one actually, it's not hard, but it requires some algebraic skills. A little bit. Okay, so what I'm going to do is I'm going to assume u equals to x minus 1. And obviously, if I take a du dx and take a derivative of x minus 1, I get 1. So what I get here is the du actually equals to dx. Dx and du are the same thing. But from here, we need another piece of information. We can get another piece of information, right? Because as we're doing this substitution, looking ahead, right? Dx can be replaced by du, no problem. And here we have x, we have root x minus 1, that's just square root of u, right? Square root of u. But how are you going to replace x in terms of u? That's how we can get solving for x. So we get x equals to u plus 1. We add 1 on both sides. So x is changed to u plus 1. There. Boom. Dx is changed to du. And we're not done yet, right? Because we have to change these two numbers on the top and on the bottom. And there comes the table, okay? So we have the table with x and u locked in that relationship, and x is from 1 to 2. When x equals to 1, right? When x equals to 1, you can even bring this relationship here, really, okay? And what it does is that if x equals to 1, you just substitute 1 minus 1 is 0. When x equals to 2 minus 1, that's a 1. So the interval changed from 1 to 2 to 0 to 1. So now this substitution is complete. You can also see why it's called substitution method. What is additional to compare to the previous two examples is that sometimes we need to derive more relationship in the substitution process, which we already did. Okay, so everything is completely substituted. So what you need to check is that you have completely u here, du, not a single x, and interval is also changed for you. So there's three parts we need to change. The function itself needs substitution. Dx need to change to du, or dt need to change to du, and the interval need to change. So there's 3 changes, all happen in one step. 3 changes all happen in one step. All right, excuse me. All right, so now what do we do? Well, we're going to have to distribute, right? We're going to have to distribute. So root u, we're going to see it as the u to the power half, right? We're going to see it as u to the power half. And we're going to take u to the power half, multiply u, and u to the power half multiplied by 1, right? So, and what do we get? 1 times u to the power half is u to the power half. And these two, we have the same base, so 3 raised to the power half. You can do this all together, right? So from this step, we get to the next step. Equals to, and now you can separate into 2 integration or just do it at once. Okay, so I'm going to do it at once. Okay, so I'm going to move it down here so you can follow. Hopefully this is easier, right? The antiderivative for u to the power 3/2 that antiderivative is 1 plus 3/2, right? And then u to the power of course, 1 plus 3/2, and that's equals to 5/2, right? 5/2. So we just do it in our head, plus the antiderivative for u to the power of half, right? We're going to have, we apply the power rule. So that's going to be 1 plus half. 1 plus half is 3, is 3/2. So u to the power of 3/2. Okay. And that's the antiderivative. But this is a definite integral. So we're going to have to evaluate 0 or 1. We're applying the second part of fundamental theorem of calculus. Okay, so the next step should be like this. Equals to, and we're going to take our time to simplify what's in the bracket. Okay, this is a 5/2. 1 over 5/2 is 5/2, right? And this is a 3/2 under 1, so that's going to be 3/2. Okay, so now we're ready to substitute. Okay, so one bracket subtracting the next bracket. But the first bracket will be substituted by 1, so replace u by 1, replace u by 1, and the other one replacing u by 0, replacing u by 0. Let's wrap it up. Equals to, okay, this part is entirely 0, and the former part is going to be, this makes 1, this makes 1. So we end up with, that's what we end up with, right? So 2/5 plus 2/3. Find common denominator, and then we shall get 15, right? The top is 6 plus, the top is 6 plus 10, right? 16. Finished. Now, once again, I like to show you how to show work. Okay, what is the ideal format of showing work? Okay. Showing work. We prefer you show work this following way, and very nicely and very clearly. Okay, so number 1. That's the main part, you show work. Okay. Side by side. And the other work we did, okay, screenshot it. And put it by side. Here we go. So you can show your work side by side like this on your paper. Okay, if that's clear. Okay. So that's the third example, and I'm going to do the last one, and then we're going to close this lesson. Okay. This one is related to, actually, we haven't done anything. Yeah, the first one is a trig function. Maybe we do another trig function, okay? But now let's do this logarithm. Okay. We are going to assume, okay? Why? We're gonna assume u equals to ln x. Okay, you think about derivative equals to ln the derivative ln x is 1 over x, so that would not surprise you, right? So du dx is equal to 1 over x. And as a result, we know that du, right, is equal to 1 over x dx. We already have it. Du over x, right? This is du over x, 1 over x dx. So this piece is dx over x, that's du. So in that substitution, what do we get is that dx over x, that's du. And 1 over root ln x, that's 1 over root of u. Right? Substitution almost complete. We have to substitute for u because the interval is going to be changed for interval for u. So next, we're going to make that table, right? So for x is e to the power 4, right? And for u equals to ln x, u equals to ln x. So when u equals to ln x, this is ln e. When x equals to e, replace x by e, ln e equals to 1. And the next one is ln e to the power 4, and that's equals to 4. So the interval is going to be changed from e to the power 4 to 1 to 4. And that would be a complete change. That would be a complete change. And next, we're going to finish up. And the whole thing can be seen as u to the power of negative half, right? And then there's the power, right? The power rule. So it's 1 over 1 plus negative half. I'm just following the power rule for antiderivative faithfully. So that's going to be u to the power of half, right? 1 plus negative half is half, right? And what else? Finished. That's the antiderivative part. And then we just have to plug in the numbers, which is 1 to 4. Equals to, right? We're going to organize the term a little bit. So this is going to be half. 1 over half, that's going to be 2. No, this is 2, right? And then we're going to plug in the 4 and 1, applying fundamental theorem of calculus part 2. You can keep the 2. You can keep the 2 inside. You can leave the 2 outside, right? So in other words, you can do this, right? Bring the 2 outside. So when you plug in, you don't have to worry about the 2. So bracket. So that's going to be u to the power of half. When u is 4, subtracting u to the power of half when u is substituted by 1. There, 1. Okay? Equals to 4 being taken square root. That's going to be 2. 1 taken square root as 1, so 2 minus 1. So in the end, equals to 2. Okay, so let's look at the show work part. Show work part, I think you already got the hang of it, but I want to be consistent, okay, to show you how to show work. Okay, make the fonts a little smaller, otherwise I cannot keep them in one shot. There. Okay, so from beginning, so the screenshot here, from beginning to end. Let's see. Let's see again. There, right? You already know the drill. One piece on one side of your paper. You should work like that. There could be variations, okay? There could be variations. I'm not saying this is the only way to show it, but this is one way to show it and show it clearly. The second part you want to put side by side is this piece. Okay, so I'm going to put it side by side and make some adjustment. So that'll be some work you can show, all right? The main work properly, shown with equal sign. Okay, so the reader can follow. Completely X, completely U with all interval change. Once again, when we do substitution, there are three parts need to be changed. The first part is the function part. Okay, I'm speaking of this from the substitution rule itself, right here. Okay, so there's a change part from all of X. This part need to be changed to all U in terms of U. dx changed to du, and dx du has the relationship. And the next part is the change of interval. So three changes takes place in one step. Okay, three changes takes place in one step. Let's see if I should do one more trick questions. Trick question. We have only one more trick question. And the other one is 61. You guys may wonder 61, right? So I'm going to do 57 and 61. Okay. So integration from 0 to pi over 6. Pi over 6. And we have sine of t. Oops. Sine of t cosine squared of t dt. That's one question. 59. Oh, wait. We did 59. I'm talking about 61. Okay. 61. We have the interval is from negative pi over 4 to positive pi over 4. Boom. Positive pi over 4. Okay. And the function is x raised to the power 3 plus x raised to the power 4 times tangent x dx. We have these two questions. Wait, how did I get that? Oh, that's pi over 4. Wait, my bad. Sorry, pi over 4. I just have to type it. Okay, so these two, the last two questions, we're gonna go over. Bring this over above okay. So the first one, or the second to last, we have of course, we're going to do substitution, right? We're going to do substitution. But what are we going to substitute? Are we going to substitute a sine t or a cosine t? Okay. Actually, we're going to use u equals to cosine t. Okay. The derivative with respect to t is negative sine t. Okay, the derivative of cosine is negative sine. As a result, okay, I think you start to seeing it, du, or you probably already seen it, minus sine t dt. Okay, so we already have sine t times dt, so that's negative du. So sine t dt is equals to negative du. So the substitution can take place pretty quickly, right? Because cosine squared t is in the denominator. So 1 over cosine squared t, that's 1 over u squared, right? And sine t times dt times sine t times dt is negative du. So we get a negative du. That's a complete substitution on the second part, right? So we have 3 substitutions. Substitution on the function, substitution from du, dx to du, whatever, or dt to du, and the last but not least is the interval. So now we got the interval from t to u. Okay, u equals to cosine t. Okay, so t runs from 0 to pi over 6. So when t equals 0, cosine t, okay, cosine t is a cosine 0. Cosine 0 equals to 1, and cosine pi over 6. What is the cosine pi over 6 equals to? And that equals to root 3 over 2. Okay, so now we're going to finish up the last substitution, right? The last substitution is 0 changed to 1. 2, the higher, is root 3 over 2. So this will be a complete substitution. Of course, we're going to finish, right? When we try to finish this, we're going to bring the negative sign outside. But at the same time, you might notice that root 3 over 2 is actually smaller than 1. So if we switch these two limits, we switch them, right? It will generate another negative sign. So negative will make positive. So from this step to the next step, we have one negative sign. There's when let's generate another negative sign by switching from A to B to B to A. So now we're almost done. What is the antiderivative 1 over u squared? It's negative 1 over u. Use power rule. Okay, use power rule. You get a 1 over, it's a negative 1 over u. Evaluate at root 3 over 2, right? And at 1. Oh, wait a second. My bad. We're not going to switch. Okay, we're not going to switch. Because 1 is smaller than that, right? Because 1 is smaller than that. So we're going to, forgive me. Okay, so we just bring the negative sign outside. We're not going to switch the ABBA. Okay, we will get another negative sign after we do. So we have a negative sign. There's another negative sign for the antiderivative. So that's going to be negative 1 over u. Okay, and of course, this is negative makes positive, right? And then that limit So that's how we get rid of the sign. We can, okay? And so one is, the lower limit is root 3, oops. The lower limit is root 3 over 2. Okay. The upper limit is 1. Okay, plugging in. We get a 1 over 1, subtracting 1 over root 3 over 2. Root 3 over 2. There. Simplify. So we get a 1 minus 2 over root 3. 2 over root 3. Wait, did I make a mistake somehow? Cosine pi over 6. Cosine pi over 6 is root 3 over 2. Yes, I'm right. Okay, sine pi over 6 is half. Cosine pi over 6 is root 3 over 2. Okay, sines. Yes, we're good. We're good. So if you want to rationalize it, oh wait, what did I do? So this is going to be 2 over root 3. This tells me I'm a little tired. Okay, it's just time to take a break. Okay, so it's 1 minus 2 over 3 root 3. And your professor usually will be content with that answer. So now, last but not least, to show work. Of course, you always check your work. You always check your work. Okay. How to show work side by side. Wait a second. Here we go. Okay. I'm going to show you this screenshot. There we go. Okay, show work side by side. Oh, we have one more. Sorry. We have one more. We finished. No, we have one more. So I can do it. It doesn't take too long. Okay. And the next part we put side by side with. Okay. So this piece side by side. So we show work nicely. So that's how you can show your work side by side. Okay. Which we encourage you to do. Okay. All right. Last but not least, this one. If you think of substitution, we certainly do because we have been doing substitution. But how do we substitute? What are we going to substitute by, right? Are we going to do tangent x, substitute tangent x for you? We're going to substitute x raised to the power 3 for you. The derivative of x to the power 4 certainly is 4 times x raised to the power 3, but that doesn't take us too far. Okay, you may try. You guys may just stop the recording right now and try something on your own. Okay, but after you tried it, you come back, you look at my solution. Okay. I have noticed that the interval is symmetrical with respect to the origin. Okay, there is a property we have never used. There is a property that we have never used, which is this property. Okay, I'm going to scroll down the flashcard. I'm going to scroll the flashcard. And one of the property is, you probably don't show on the, on your screen, but that's okay. Okay, I will show it to you. This property is integral of symmetric functions. Okay, so you go through your flashcard. This is the property. So now you see it. Now you see it. The second property of this screenshot is that when a function is odd, when do we start to examine if odd function, even function has any role in our integration? We've been doing, substitution all along, so we only think of substitution. But sometimes we need to take a break to say, okay, oh, wait a minute, we have an interval, right? It's from negative a to positive a. The next question is this function odd? Is this function odd? It looks like it is. It looks like it is, right? So we're going to assume that this function is f of x, right? It could be integrated on that interval with some interesting features from negative pi over 4 to pi. But we need to show the function is odd. So to demonstrate the function is odd, we're going to use a definition. So we're going to plug in f of negative x. What do we get, right? If we replace f of x by f of negative x, all the places with f of negative x is, all the x will be replaced by negative x. And tangent function is an odd function. Okay, tangent function is an odd function, meaning that tangent of negative x is negative tangent x. Okay, tangent is odd. So at this point, what we have is that we have equals to negative x raised to the power 3 is negative x raised to the power 3 plus x raised to the power 4. Okay, and negative x to the power 4 is the same x raised to the power 4. And tangent negative x is a negative tangent x. We're going to plug in. And what do we get here? Okay, because here we're just trying to see if the definition of odd function applies. So the negative sign on this piece will be brought to the front, negative. And then we can factor out the negative sign, right? So that's going to be x squared plus x raised to the power 4 times tangent x. So we factored out the negative sign. And what is this? This is exactly negative f of x. Okay? That is, okay, you have to put it, you have to put in words. This function is odd. F of x, this function indeed is odd. It's odd. If this function is odd, according to this theorem, right? And we have a symmetrical interval right there. Therefore, this integration is going to be 0. You don't need to do any substitution. That's all for this lesson. Thank you for watching.